So welcome to Algebra 1. My name is Chastity Bridges, and today we will be covering functions. So as you look at this picture, I want you to take a minute and think of what you see here. What questions do you have about this picture?
Why is it so green?
Why is it so green?
Why is there so many gumballs? How many quarters is it going to take to get all those gumballs out of there?
How many quarters is it going to take to those gumballs? So that leads us into kind of directly what we want to talk about functions for, because those quarters we're going to put in to turn to get our gumball, and it's going to give me a gumball out. And that's, as we talk about functions shortly, we'll talk about that connection of that number of gumballs in there. We can put lots of quarters in now, but it's giving me that gumball out. Let's see if I can get moved to the next page. Oh, really? There we go. Okay, so understanding functions, we're going to look at representations, rules, and real-world connections. So, what is a function? The definition of a function, it is a relationship where each input corresponds with an output. And what that means is that we have an independent or x value that those quarters example are that input that are going to give us an output, which are the gumballs. That when I put it in, that quarter in, and I turn, they're going to go down, and then it's going to give me that output. And you'll notice these machines here, these are what we call algebra machines. We are putting in a number at the top, and that number is going to be that x value. And then it's going to give me, I'm going to do that using the order of operations, that side, and then it's going to spit out another number. So that function that's there is what is happening with that machine. It's that gumball spinning all the way down until it's my output. Okay. And it went the other direction. This board is being... So, as we look at functions, we have different representations. The first representation is a line. And this is in the form of what right here? What?
Y equals mx plus b.
Y equals mx plus b, which is slope-intercept form. We know always that if we have a linear equation, that is going to be in the form y equals mx plus b. And it's going to create a straight line. Now, the second one is y squared equals x. Now, let me go forward to that one. So what happens there is our x, we're squaring it here. We're going to have to take the square root. I got too close to the board. The square root of both sides. So what's going to happen is that's going to be half of a U shape going in this direction. And it's going to end up being the whole thing, because when we plug in a negative, it's going to change it to a positive. And, well, it's going to give us both. It's going to give us a 1 and a negative 1 answer over here. So it ends up being a U to the side, but when we take the square root, it ends up being just the top, but it's a plus or minus that, so it's going to give us the top and the bottom. So it's going to look like a C. Now, and we're going to talk about the vertical line test in a moment, but a vertical line test is if I take a line and go across, it's only going to touch my graph once, showing that I only have one x. Because if you look here, that line only had one x value for each as we went across. And so it would pass that vertical line test. So if we look at a table, let's talk about those inputs. Earlier we said for every independent, that independent only happened once. That quarter, we could only put one quarter in, right? Mm-hmm. And it's going to give me that something out in that function. Here, I'm putting in a 1, and then I'm putting in a 2, and I'm putting in a 3. Those X's, that independent never repeats. But what's happening over here on number 2?
It's repeating. There's 2 1s.
There's 2 1s. So the independent is happening twice. That input is happening more than once. So, and it's giving me those outputs. So from 1, we're gonna have 2 arrows when we do a mapping. This is an example of a table. The last one was an example of a equation. Our next example is a mapping. So you're gonna notice our ordered pairs here, which are going to be our X and our Y, are going to be A1 and C3. We don't have any other arrows, even though we have groups. So A, is that going to be a function or not a function?
A could.
A could, because there's not, it only has 1 going. What about B?
Not a function.
Why not?
Because C is going to both.
Because C is going to 2 and C is going to 3. Now, what about C?
Yes.
Yes. Now, where could that possibly trip you up?
Because there's 2 going to 3. Yeah.
There's 2 going to 3. Our outputs can repeat, our inputs cannot. Okay? So, going back to that vertical line test, I always like to take a pencil, and that becomes my vertical line. Vertical lines are straight up and down. And so as I go across the page here, is my pencil going to touch that graph more than once? And remember, it goes on forever. It doesn't. It's only going to touch once. But if I come over here to that C shape, right there, it's going to touch at the top and the bottom. Okay? So that's why this first one is a function and the second one is not. Those X's repeat. And that's... The definition can be a little confusing. That's why I always like to say your X's aren't going to repeat on a function. So the vertical line test is just taking a vertical line representing a single input value. So that input goes across, it's only ever going to touch once. If it touches the graph more than once, there's more than 1 output. So that C shape a second ago, that was an example. Therefore, it is not a function, and I had a mistake there on my screen. So if it touches more than once, it's not a function. Right here, not all functions are practical. This is that square root function. It passes the vertical line test. But in the real world, it doesn't give us any negative examples. So that's not something we're going to see in a real world example. So let's look here. Domain and range. Domain are all of our X values, are all those X inputs that we plug in, while the range are all of our Y values. So our example here, we have Y equals 2X plus 3. So what is our domain? What can we plug in for X?
2.
I can plug in 2. Can I plug in anything else?
Wait, is it? No.
What numbers can I plug in for X? What could X represent here? It could be 1.
Mm-hmm.
Can I put a fraction in there?
2 over 1?
Can I put a decimal in there?
Yeah.
So, can I put a negative number in there?
No. Yes. Can you?
So, a domain, an X value, could be a negative number. So, if we talk about it being all negatives, being fractions and being decimals, and it can be negative numbers, what does that tell you that your domain is? Is there any number that I can't plug in? No. It is all real numbers.
Okay.
Now, for my range, if I can plug in anything here, it's going to give me, I can come out with any answer.
Mm-hmm.
So it's going to give me anything. So our domain and range on a linear equation are all real numbers in both directions. I can plug in anything for X, and I can get out anything for Y. So looking at our keywords, so when you think of an input, what does that make you think of?
You have to put in something
Plug
to
in
take
something
something out.
Plugging something in, and what do we normally plug in for? X. It's normally X. Can we plug in for Y?
Yes.
Yes, but we know that that's our normal output. What do you think of with output?
You're taking something.
Is that your Y?
That's your
Yeah.
Y.
That's what it is.
And so that's what we get once we've plugged something in. Mapping. Which of those that we covered earlier was a mapping?
The long ovals.
The long ovals. And one of them represents what?
A function?
They could be a function.
Input and
Input
output.
and output.
Input and output. When would they not be a function?
If they don't pass the vertical line test?
If,
Okay, remember these are the two ovals.
if
Okay.
two go to the same.
Oh, yeah.
Two go to the same one. Very
My
good.
bad.
So function, how do I know something's a function?
Straight line on a graph.
No.
Oh, it's,
Wait.
If it passes the vertical line test.
if it passes the vertical line test, how else would I know? How would I know from a mapping?
If each one had a single one.
A single
every-
one?
Input had one.
What about from a table?
If there wasn't repeating numbers
If the X.
on X's.
If the
X's
X's
repeat.
aren't repeating, the
Very
outputs
good.
can repeat.
So a relation is, we're looking at the relationship from those. We're looking at each of these things we just looked at were relations. Domain, what do you think of with
X.
domain? The X, what about range?
Y.
Y.
And the vertical line test, how do we do the vertical line test?
If it's only touching the graph once.
If it's only touching the graph once. Okay, so real world examples, think of a soda machine. And we started with the gumball machine where we put the quarter in and we got the gumball out. Soda machine's another example. I go to the big soda machine, I put my dollar in, it gives me my Coke out. What about a soda fountain? I got my cup and I walk up to the soda fountain. I can get Coke put in that cup, I can get Sprite in that cup. That is an example of not a function because it's giving me more than one thing.
Yeah.
Real world example. So, why is, and I want you, this takes a little thinking, why is the vertical line test reliable?
Because if it wasn't a function, no. If
You
it
can see that it's going to work. Like you can see if it has.
You can see it, but what does that represent by being able to see it?
that it doesn't have two X's
Awesome.
on the same Y.
It doesn't have two X's. That is perfect. Can a graph pass the vertical line test but still not be a practical function?
Yeah. The one with the only.
So the
Yeah.
square root, y
Yeah,
equals
that
the
one.
square root is not practical, but it does pass the vertical line test. That was a good example. How do you recognize functions in real life?
The soda thing.
Yeah.
The soda,
Real life.
so something that we put in and we get one thing out.
Mm-hmm.
Okay. What would happen if a function had two outputs for one input?
It's still a function, isn't it? No.
Two
Yeah.
outputs for one input.
Think of the mapping. One number. Two
Oh,
numbers.
it's not a function.
It's not a function. Very good. And that's a good representation. That visual look there. Okay. So what we learned are functions are special types of relations. They're represented as equations, tables, mappings, and graphs. We have different ways that we can see those. Vertical line test is a visual way of us identifying. The real world connections help us deepen our understanding, and always consider your domain and range. Okay? Now, so as we finish this up, we want to look at real quick just a couple of questions. We went over there at the end. What, if you're given a graph, what are you going to use to determine if your function, if it is a function?
If it only touches one time, right?
If it touches what one time?
That.
Lines.
Yes.
A vertical line. Very good. On a mapping, How am I gonna know if it's a function and a mapping?
If each one only has like going to one.
If each
out.
X,
If, yep.
each input has an output.
Now, can the outputs be doubled?
Yeah.
No.
No.
Can we have two different inputs
Oh.
going to the same output?
Yeah. Yes, two different inputs, but the
Not
two
two different outputs.
outputs can't go from the same input.
Very good.
It's a tongue twister.
And then on a table, how do we know on a table if we have a function?
If there's only one of each X.
Only one of each X. So we are going to do a visual representation on Canva. So a couple of things that I just want to remind you of is as we're a one-to-one school, and we have got to, each of you have your computer and have gone through the guidelines of the school. Make sure that your work is your work. We want to make sure that you are, if we use a picture, that you have access to that. We've gone through ways for you to pull pictures that are free. Make sure that you're not cheating, that you're not just taking somebody else's work. AI is now a big thing, so we want to make sure that you're taking your original work, because we can't, with what I'm looking for and what will be on the rubric at the end, we've got to make sure that it covers everything. And just the safety, make sure you are being safe with your computer. Make sure you're not sharing your password to anything with anybody. So we're going to create a visual of what is a function that clearly communicates your understanding of the concept. We're going to follow the directions below to ensure the required components are included. Canva is one of the things our school system supplies for y'all to be able to use and create things to turn into your teachers. So your title, you need to have what is a function. You're going to write your own definition of what a function is in your own words. We don't want just the book definition back. Make sure if you're using something from a book anywhere in here, or if you're using a picture, that you cite where you got it from. It should be easy for another student to understand, not copied from a book or online sources, and accurate and reflective of your understanding. We want some real world examples. Include one real world example that is a function, one that's not. Explain why each fits or does not fit the definition of a function, and add relevant visuals or icons to support your example. And then somewhere on there, I want you to take and show the representation of not your function, but give examples of a table, a mapping, a graph, and an equation, just so that I can see that understanding of each type of function that we've discussed. All these representations represent the same function and demonstrate your understanding of how functions can be shown. Label all the parts. Use at least 3 vocabulary terms: input, output, domain, and range. Add arrows, diagrams, or icons to help explain. And make sure your design is organized. You can do all kinds of things on Canva. We've used it in class previously. So what is a function? So here is your rubric, and to get all points possible, it is not taking me that, so I will print that out and give that to you so that you can have that to begin.